initiatives in agriculture education. So we have with us Dr. Sudeep Parwa from ISRI. I will briefly introduce you to the speaker. Dr. Sudeep Marwa, are you there? You can switch on your audio and video. Yeah. So, friends, we have with us Dr. Sudeep Marwa, who is working as principal scientist as well as head of the computer application division at ICAR Indian Agriculture Statistics Research Institute. He has more than 21 years of experience for postgraduate teaching, training, research, and over and above that, he has developed multiple information systems, softwares, which almost everyone in NARS is utilizing in one or the other way. And he has guided over more than 14 MSc students and PhD students and published in national and international journals, conferences. Before that, he completed his PG in computer science from IRI and PhD in computer science from University of Delhi. And he is PI of very prestigious project, NAHIP, National Agricultural Higher Education Project. So where he has been working as PI, and also in a subsequent follow-up project of that is NAHIP Resilient Agriculture Education System, in which number of IT initiatives have been undertaken to improve the higher agriculture education system. His research interests include development of intelligent systems, recommender systems, management information systems, artificial intelligence based systems, and also application of image analysis for estimating plant pigments. We have seen one such applications in one of the previous lecture too. So with that, I think there can be no one else more suitable than him to give an idea on all such IT initiatives for agricultural education. So you being all from agriculture education, I think it is appropriate to make yourself aware of these initiatives. So you'll get first-hand information on that, and you can ask any question or any doubts or any feedback related to that. With that, I would like to invite Dr. Sudeep. So you please carry on with your presentation, and thanks a lot for accepting this request to be part of this training program. Thank you. So Dr. Sudeep.
Thank you, Dr. Rajni. In fact, thanks for giving me the opportunity to interact with the participants. And it's always been a pleasure to have at least one session in such training programs, wherein we can actually deliberate directly with the participants who are also our users of various systems. So as Dr. Rajni has told that I'm involved in multiple initiatives, and she's also involved with me in multiple such initiatives, sometimes as a team member, sometimes as a nodal officer. So she knows the whole journey, right from the beginning, 1999 onwards, when we started this development. And way back at that particular point of time, it was just the starting of this internet era and IT-based systems, more specifically internet-based systems. So right from that point of time, I was involved in those type of systems. I think just a minute, I have to plug the battery in. I think 1 second. Right, okay. When we started this journey in 1999, it was initial days of internet-based programming, and the technologies were CGI, Perl, and starting with the initial days of active server pages, then Java server pages come, and so on and so forth. So based on multiple such technologies, we started our journey, and we started with the system called as there was a World Bank project, NATP at that particular point of time, National Agriculture Technology Project. And we started with this development of project information and management system. And with that basic uh, first system which we have developed, and that system was implemented across India. And we have this NATP project information and management system. So 845 projects were there. And so 845 PIs and number of co-PIs and CCPIs, etc., who started filling the information on their projects so that the monitoring and evaluation can happen on online. That was actually my first project. In that too, also we started with first standalone system. So we developed a Visual Basic front end and a MS Access database. And then we used to gather this MS Access database uh, on some CDs or floppies from various centers. And then we merge it here, and then we collate and then present the complete picture to our top management. So that was the scenario at that particular point of time. And then we moved to internet-based, ASP-based system, wherein all of these things we need not to do, and we carry on with straight away data entry on the internet-based systems, and all the correlation happens automatically. That was the first project wherein we got uh, quite a motivation that these systems can be implemented at ICR and AU level. And then we move forward for another system which we were actually working on from 1995 onwards. Uh, Basically, it started with the DBase 4, and wherein it's more of a DOS-based system with some data, then Fox Pro, and then eventually to MS Access, and then finally to SQL Server. So that was a journey of the database from DBase 4 to SQL Server, and that system was called National Information System on Agriculture Education. That system also a long journey, and now the name was there NISAGNet till 2015-16, and then it with newer functionalities and new version, it is now known as Education Portal of ICR. So then NISAGNet system, National Information System on Agriculture Education, which is now known as Agriculture Education Portal of ICR, has been developed. And since then, the system has a long journey, and the type of functionality it delivers now has also come a long way. So I'll be discussing about all these systems, and many more systems have been developed uh, in parallel based on multiple requirements from the multiple organizations. So this is a glimpse of these systems which are now available to all the users. So these are a dozen of it systems, and systems plus what you call it hardware environments, like that. So I'll be discussing about all this system one by one. And of course, over it, there is a system called Education Portal, which I just discussed about. So let's see what is Education Portal. So Education Portal, ICR, is a single window platform for providing vital education information, announcements, event schedules, e-learning resources, from agriculture universities across the country to the rural youth in an easy and fast way to their doorsteps. So the outreach is all 74 AUs that comprises of three central AUs, that is BHU, AMU, and Nagaland University. Four ICR deemed universities, that is IRI, IVRI, NDRI, and CIFE. 63 AUs and four central universities with agriculture faculty. Sorry, these four central universities with agriculture faculty are Banaras Hindu University, Aligarh Muslim University, and what do you call it, at Bengal, Vish Bharati, and then Nagaland University. Then three central AUs are your RLB CAU Jhansi, Rajendra Prasad Central Agriculture University Samastipur, and Central Agriculture University Imphal, covering more than now 2 lakh users. And the portal has been developed as an initiative of ICR under the Digital India program of Prime Minister of India. We have now very intuitive and latest design on the portal, and its next version, that is Education Portal 2.0, is also in development and will be released soon. So if you see these systems, I'll also after the class will this brief presentation, we'll see the system directly. I'll try to open our browser and show you the system. The next system which was developed, it was initially developed as a management system for postgraduate education for IRI New Delhi, wherein we tried to completely automate the working of PG School of IRI from the student admission to pass out. So one by one over the years, multiple workflows have been developed, and the complete system is online. It started in 2007-8, and since then, from development started in 2007-8, and it became operational in 2009-10. And since then, that means almost 12, 13 years, we are able to manage it, operationalize it, use it in our day-to-day life. And once this system has actually implemented in multiple other AUs, then this name changed to Academic Management System, because now not only postgraduate education, but undergraduate education is also now being operationalized and automated through this Academic Management System. So this system, basically all these systems, whatever I am going to cover, these are salient features and the basis on which this system has been developed, and the main bottom line is to have these 5 or 6 type of functionalities or key performance initiatives or paradigms on which we have developed these systems. And these systems, these salient features includes more transparency, enhanced efficiency, user friendliness. It facilitates automation and role-based access to various users, and robustness and ease to customize as per the need of the various universities. So the users of these systems are all of us, like starting from the vice chancellors, deans, registrar, professors, heads, guides, faculty, teachers, students, administrators, and officials who are sitting at the university office for performing their assigned tasks. So system has been designed in a modular approach and has built-in workflows. So the essentially this system is a set of workflows. So there are 12, 13 workflows. Mostly these workflows start from the student, goes to the guide, then the head of the department, professor, registrar, dean, and so on and so forth. Some workflows start with the guides, some workflows start with the admin itself, and it just goes to the professor and registrar. And some like course and examination modules start with the main faculty. So as of now, there are 52 registered universities. So this journey is again is a long journey which started in 2008-9, and since then, from a single university in-house development for our own use, uh, we have gone to 52 universities, and recently we are now in a way gone international also, as Anastu IRI collaboration is also managed through this academic management system. So 462 registered institution colleges, more than 24,760 registered students, and 7,081 faculty members. So some of the new feature which we are trying to implement through this system is we have not actually made it fully operational, but this we are trying to get it done, which is University Academic Health Index. And through this, one can actually find out what is the status of various activities of your university. So any vice chancellors, dean, directors can actually see uh, what are the various parameters and how the university is performing. And this covers various programs, various workflows, and a sum together of all of these to just tell you in one way whether the university day-to-day functioning is being done on time or is being delayed, or certain activities or certain things are not as going as per schedules, and various other impacts based on those delays or uh, things like that. So we are working on that, and hopefully we'll come up with this dashboard, new kind of a dashboard very soon. It also has an incident management system in process, so that the incidents which happens can be actually taken proactively, and solutions can be made. So the next system, which each one of you should at least see and try to log in, is Krishi Vishwavidyalaya Chhatra Alumni Network. We call it KVC-LNet. And this is a system which is a central system for the alumni network of all 74 AUs. So up till now, we have some universities which have a good alumni website, and some even don't have it. Some have having very uh, preliminary website, and some are just giving some information in their websites, general websites with certain PDFs, etc. So there is a huge variation when it comes to the alumni network based system. This system KVC LNAT, as its name says, is for everyone, all 74 AUs. And this is actually almost a full-fledged social networking site, having multiple type of functionalities, wherein a student can actually interact with their fellow alumni, and they can chat with each other, and many multiple things are there in this system which a student can use it. And alumni also can actually interact with each other through this system, and they can also put their uh, various type of internships and placement programs on this portal, so that the students can be benefited out of it. So this is very important system which we have developed, and we are trying to uh, popularize it. So if all of you actually register in it and ask all your in your WhatsApp groups and other things, if you uh, popularize it, this will be a great system in near future, where all our alumni, all our students can interact with each other and get benefit out of it. In this, we are soon going to also implement a payment gateway wherein micro or macro donations can also be given to your universities. Then the next system which is there is the accreditation portal for agriculture higher education institutions. In the pandemic time, this is the portal which allowed ICR to maintain its usual operation, business continuity, for accrediting various universities, colleges, and courses. And under this system, we have made uh, basically a full-fledged workflow-based system where a university can apply for accreditation for either a single course or for multiple courses or for multiple colleges and so on and so forth. So it starts with the letter of intent on online process, then institutional eligibility for accreditation, then statement of compliance, and then self-study report. Uh, this way it gets into the complete workflow-based system, and the information of being accredited or not is also uploaded onto the system. So this system is fully being utilized by the ICR Education Division for making this process completely automated. So as you know, as I told us, each there are multiple features of this system. Each user or university can create their own login credentials and are provided with their role-based access, and to monitor the uh, to monitor progress on the application. So a user can also actually track. Earlier, it was very difficult when a universities or a college submits its application, so is not able to actually know what is the exact status of his application at a particular point of time. So now he can actually track his application, and he can know from where this application is there and how many more days it will require to finish. More like of an your paper submission status. Many journals show whether the paper is in review or is in first reviewed it, second referee reviewed it, it's in acceptance mode, or it's in like that. So similarly, the accreditation system also allows the university to track its application. The portal also hosts a communication channel that automates and provides information regarding all these status at different steps. So it is essentially also mm, increases the transparency, it is user friendliness, robust, and a dashboard based monitoring is can be possible with this system. So the next system which we worked upon is Agriculture University Ranking System, which we call it AURS. And from last 2 years, this system is in operational, and all the universities, agriculture universities, are being ranked from 1 to N on this system. So universities actually apply for various uh, these positions, and based on the predefined criteria they are ranked. The predefined criteria are well known to all the universities, and it includes teaching resources 30%, research 30%, extension and outreach 30%, and peer recognition 10%. So based on these four categories, multiple sub questions are being developed, and based on those questions the universities uh, put their data, and we tried that most of the data is can be taken from the source itself, and so that the verification of the data or the claim of the university for a particular achievement can be ascertained. So it's very important that these universities who are participating in this ranking system are actually being ranked genuinely and based on the actual facts and not on the fictitious data. So because of that, many we have restricted the entry to a very bare minimum level, and most of the data which is publicly available is taken, and this process will be strengthened more in future, and more data which is in public domain will be used for ranking the universities. If the data is not available in the public domain, the university will not be given due weightage or due rank. So all the data which should be used for ranking should be made available in public, and based on that data only the ranking will be made possible. So as I told, this system also it facilitate automations. This is there is a MIS dashboard, and it's developed on strict policy guidelines and simple and quick access, and obviously it's transparent, efficient, and user friendly. The next system which we developed is e-learning portal, and this e-learning portal we have developed in this NHEP program, and with this we tried to have 144 PG courses online, and based on multiple categories, the e-learning content, the slides, the PowerPoint slides, the MCQ questions, long answer questions, and many other glossaries and other things we tried to develop. Rather, we tried to give all the faculty a platform wherein they can develop and upload it as a central platform. And based on this central platform, all the courses which are developed, we are also issuing certificates. If the minimum criteria to become a course developer is basically a assistant professor or a scientist having 5 years of experience. So this is very important area wherein we actually allowed most of the faculty from the university system who have 5 years experience and at least taught a particular course twice or thrice. They are allowed to develop that particular syllabus, and based on their inputs, we enhance the various um, PowerPoints and other training material which they uploaded, and bring them into a common platform or a common format, and then publish it through this system. More and more enhancements will be there in near future in this particular system. This system will also be integrated with a larger system. So this will be a common system for all the faculty and everyone to access, to have a reference course material available for all UG, PG, and PhD courses. It's a huge task to have e-content for all the UG, PG, and PhD courses. We have started a beginning, and let's see how quickly we can finish all that. But it genuinely requires support from all the faculty. We can't do it alone, and neither we have planned to do so alone. So this is a common system and for everyone, and we are trying to also make it more operational in a sense that most of the whatever type of information we want to access or have it on a from a student's point of view, we can build into it. Just a minute, there is a call from ICR. Have to take that. Just a minute. हेलो. हाँ जी. हाँ जी सर. हाँ जी सर. So, so based on I was at okay. Right. So these courses under e-learning. So there were 343 UG courses were also there. In the so the whole system is divided into multiple calls, like mm, research funding organizations have multiple calls for the funding. So similarly, these courses were developed under multiple calls. So we have up till now 4 calls: call 1, 2, 3, and 4. And call 1 and 3 are for the PG courses, and call 2 and 4 were for the UG courses. So earlier in the NAIP period, we have developed UG courses. So over a period of time, those courses were based on fourth or third Dean's Committee report. So now after fifth Dean Committee report, we have multiple changes in the courses. So we wanted to actually review those courses and then upgrade it and everything we want to do. So all that we have done. And this is both call 1, 2, 3, 4. These calls are in process. Obviously, the courses are allocated, but at various level, these courses are being developed, and we are working on it. So many courses have gone live. Then the next system, very important, is Agriculture Experts Information System, which is called as AEIS. And under this system, our Honorable DG wants that they want to have a database of all retired, in service, and all other type experts at a central place, wherein he can choose a particular expert from his own way and as per his requirements for assigning certain jobs, placing them in certain important committees, and so on and so forth. So you want a central database wherein discipline wise search is also available, keyword based search for various key technologies or key skills are also available, so that he can actually do it hurriedly and whenever he requires on certain few clicks of the mouse of the clicks of the mouse. So this system looks like this, and it has profile for every scientist, every faculty, every expert, and they can have their own name. Suppose we can have a system like ais.icr.gov.in slash Sudeep Marwa. So this name you can actually print it on your visiting card. You can have this web page available as a part of your signature in email. So this will be your central profile, uh, and you can maintain it and manage it across AU, ICR, whether retired, in service. That means in all way throughout your life. So it has multiple, as I told, multiple initiatives like creation of a committee, and these committees can be actually developed by the ICR at various levels, the AUs at various levels, the ICR institutions at various levels. The next system is Agriculture University Project Information Management System. As I told, we started the journey with this system, which was then only limited for NATP, National Agriculture Technology Project. But over a period of time, we then from NATP PIMS to we have come from PIMS ICR, wherein the PIMS Project Information Management System for all ICR institutions have been there. And after that, we thought that since um, since agriculture university also involved in research, so it will not have a complete directory of all the project unless until we have AUs also in it. So we have this AU PIMS fully functional, and up till now more than 59 universities are registered. Projects have also gone significantly higher than 600. More than 650 registered PIs are there. So multiple information type of information is available in this system, and is you can use it for your project reviews also. Then the next system which we developed is actually Krishi Megh, and this system uh, is essentially, it's not a software system, but is the mother of all systems in terms of the data center as well as the disaster recovery center. So under this initiative, we have actually tried to create a NARES cloud and to provide all the basic level of IT infrastructure services to the ICAR as well as to AUs. Earlier, under the National Agriculture Innovation Project, the ICR developed its own ICR data center, and it was functional very since 2014. We have remarkable achievements under this ICR data center, wherein we have not a single minute of unscheduled downtime because of the services of the ICR data center, and all the services like e-office, email, ICR, ERP, and all these systems which I just told are operational from this ICR data center, and it is have become very critical for the lifeline of the ICR. Now in the pandemic, the complete ICR is 100% dependent on this ICR data center, and because of the services which are provided through this center, and so it has become very important to back up all these uh, crucial databases, information, and other things at certain other place also, because of if any disaster happens, maybe man-made or a natural disaster, maybe earthquake, maybe fire, maybe some flood or some anything else. Uh, so we should have a backup at some other location. So we developed this replica of this center at ICR NARM, Hyderabad, which is in different seismic zone. And on a daily basis, the data is replicated to ICR NARM, Hyderabad center. And based on that type of mutual interaction between ICR Disaster Recovery Center at NAM Hyderabad and ICRDC at ISRI. That together both of these form the Krishi Megh, which is the mother of all systems. Uh, and we are providing these services to complete NARS through this system. So these are the highlights. Uh, we can say that reliability, availability, accessibility, and scalability. And this center was inaugurated by none other than the Honorable Agriculture Minister and Shri Narendra Singh Tomar ji. It has cloud-ready infrastructure, application on demand using self-service app stores, application continuity with disaster recovery capabilities, zero obsolescence infrastructure with auto migration to new platform with zero downtime, multi-layer physical security and information security infrastructure, power space cooling, basically a precision type of a cooling environment, massive reduction, which resulted into massive reduction in power, space, and cooling requirements against any traditional data center, robust and secure hyper-converged infrastructure platform from for journey to cloud that includes network and cloud security, storage consolidation, business continuity, and operations and automation. So these are the main highlights of this Krishi Megh. Then the next initiative which we took, which is a combination of again hardware and software, are virtual classrooms. We established 18 virtual classrooms across India in 17 top AUs and in ICR, ISRI. And these were the devices which were there in virtual classroom. We have a digital podium for lectures. We have interactive LCD screens. We have visualizers. We have front camera for students. We have tracking camera to record lectures. Automated recorded lectures can be recorded. Speakers at classroom for better audience reach. We have an interactive flat panel that you can use it for presenting your PowerPoint slides, videos. In between, you can augment that data as the picture shows. It also has the capability to interact with users. Like in Zoom, we also can, to a certain extent, single way communication is possible through this software, central software, which we call it Panopto. And this with this software, all the recorded lectures which are there in all 17, 18 classrooms are centrally can be accumulated together and then can be rebroadcast to all the users. So this is being done in already being done in 17 AUs and in first phase, and in second phase is right now in operational, wherein all other AUs are being considered and actually delivery has started. So in another month's time, we'll have all 74 AUs with at least one virtual classrooms which is integrated together in a form of a single system. And this system we called is AgriDiksha. So the features are like learning optimized multi-stream video recording, easy video uploading and private sharing with students, enable in-video quizzes, notes and discussions, toggle between video streams to switch focus to a different aspects of the lecture, simple online video editing. The software itself have a video editing features, automatic machine generated transcripts and captions, interactive video playback in any browser, video engagement analytics, speed up or slow down the playback speed, turn captions on and off, and configure the font size, colors, captions to their preferences, take personal uh, timestamp notes in the video player, and create bookmarks in places they want to revisit later. This is for the students. So a lot of good functionalities are there in this particular system. So these are the 18 locations where the classes have been already established, and in rest all we are doing. So we call it Agri Diksha E-Shiksha, and all these things are available now: live streaming, video search, easy integration, video management, video recording. So for teacher, essentially, you have no location constraint, anytime live recording and video upload, one-stop solution, recording and editing, attendance check, quiz, poll functionality, live interaction, webcast. For students, again, no location constraints, anytime access of lectures, quick access to video repository, can access from desktop, PC, laptop, tablets, smartphones, live interaction, interactive learning, and online assessments. So all our things are possible to an extent. Then we are in process of developing an AI-based intelligent mobile applications for pest and disease diagnosis. Under this initiative, we are working on a system which we call it NIBPP, National Image Base for Plant Protection. And in this domain of agriculture, a healthy crop is of paramount importance and critical for the food safety of the whole country. And we know that there is a huge loss we suffered because of the pest and disease identification infestations. And the primary objective is to provide the farmer a very user-friendly mobile app which can automatically detect disease and disease of plants or crops, uh, and the farmer has to simply upload the image. But for that, we need to have a huge image base, and we are developing for the national as a national image base for plant protection. And this for this selection of potential diseases and pest of plants is the first step. Then collection of digital images using an IBPP mobile app. Then develop AI model for disease and pest identification, and then prediction for disease and pest identification. So multiple these initiatives are there. Then we developed another portal called Green and Clean Campus Awards portal, and Honorable Prime Minister has given this award to 3 universities last year, and all the applications which were there are actually uh, uh, all the applications are through this central portal, which is called as Clean and Green Campus Awards, and main areas on which these universities are scrutinized are actually green cover, solid liquid and waste management, rain and roof, water harvesting, water and energy conservation, waste reuse and recycling. So based on these parameters, the first cycle of the Green Campus Awards was there last year, and this time again we are doing it with some more refined parameters. Then we have this portal which we called as Kritagya portal, and this Kritagya portal is essentially a portal to automate a agriculture hackathon. So we have 2 rounds of these hackathons already, one this year and one previous year. And in both these, this platform has been centrally used for getting the ideas from various teams. In the first hackathon, 784 participants teams were registered, and which were scrutinized at the regional level, and then at the 25 teams have come at the central level, the national level, and out of those 25 teams, only 3 were given awards. So, as the Kritagya name says, is basically KRI for Krishi, TA for Technique, and GYA for Gyan. So Krishi Takniki Gyan, Kritagya, and this year we have in the animal science sector. In the first year we have in the Indian agriculture engineering section. So two rounds of hackathon are already being done through this Kritagya portal, and probably this have become the central portal for having agriculture hackathons. Next year probably we'll see for fisheries. These are some set of systems. Before I quickly move on to the live presentation, we can have quick round of questions. Any questions?
No, sir, there is no any question.
Anyone, any questions? So thank you very much, Dr. Sudeep, for giving an overview of
So do we have more time so that I can show the demo, or this much is enough?
We have 7 minutes.
Hello. तो एक 5-7 मिनट का एक क्विक टूर टू एजुकेशन पोर्टल में कर देता हूँ.
Aunty sir. Hello. Dr. Sudeep, you can give demo in 5-7 minutes.
So this is, as you can see, the education portal, right? So there are 3 divisions of agriculture education: education planning and home science, human resource development, and education quality assurance and reforms. So all 3 divisions have multiple schemes. Like these are the various schemes in these 3 broad divisions, and all of these schemes are now almost automated. So all the things which you do under these schemes are automated, and more or less the complete education division is now paperless. So including from the fund demands to fund allocation under various schemes, these are automated. If you go down the system, you will see a lot of systems available, which some of these systems I already told you. It also has e-Granth, Krishi Kosh. It also has e-Krishi Shiksha learning systems. It have this. Another very important system is ICAR Agriculture University grievance redressal mechanism system. So all this system are in place. And if I show you some systems, and the winter school system, the CBP capacity building portal, through which most of the winter school and summer schools are organized, are also fully automated as one part of this education portal. Right, so these are multiple system, and you can actually go and search and see all the universities from here, and all the assignments and everything else now comes on this system. And if you see here agriculture universities, and you can go to any university, state agriculture universities, so you will have a list of state agriculture universities. You can click any one of these universities, and you will find a good picture of that campus. You will know about university. You will know about various information about that university. You want to read, you want to have a faculty strength information.
Thank you, sir.
So all these things are available. And I just want to quickly show one more information. From here, you can also see various events. And this is e-courses which are available on e-Krishi Shiksha, the UG level course level. A lot of courses are available here, year-wise, semester-wise. A lot of courses are available, huge amount of information. Right? You can explore these websites from here. So we have one question, I think, which portal should affiliated colleges use for applying NAC? So we are not actually dealing with NAC, right? So this is for accreditation for ICR portal, not for NAC. NAC has its own portal.
Is it over?
Yes, if no more questions.
Okay. एक क्वेश्चन तो एक ही है, which portal should affiliate
That I answered.
में
So
use?
NAC we are not dealing with. The NAC has their own
Yes,
portal.
general universities का है तो. Okay. So thank you, Dr. Sudeep. I think you have given the demonstration also. So if needed, they can see that education portal, and since all are related to agriculture education, it will be helpful to them if they are seeking some information. So thank you for joining. I know you are very busy. So thank you for sparing that 1 hour with us. So thanks a lot. Thank you. So now
you.
I think it is a time for the next session. So we will start with the next session now. It's already there with us. So I would, how are you, Dr. Aditya? You are in India right now or Germany?
I'm in Germany. Yeah.
Okay, you said you will be coming here.
Yeah. So it was postponed by a week. I'll come back next week. Yeah.
Okay. So hopefully this time is okay for you. Then.
Yeah, it's perfect time from 11 o'clock in the morning.
Okay, perfect. So this I will just briefly introduce you about the trainees and the training first. This training is being organized under SC plan of Government of India. So like some skill development and all should be there. However, we have participants from all social groups here. And the participants are assistant professor as well as research scholars. And they are interested, as you know, ICR focus on impact. So that's why we decided to have lectures on impact. And now, basically, I would briefly introduce my participants. I will briefly introduce you to my participants, basically. So, friends, Dr. Aditya is right now following his PhD at Humboldt University of Berlin, Germany. And he is also a fellow of Netaji Subhash ICR International Fellowship 2020. He has joined as a scientist at IRI since 2016, and he did his master's from UAS Bangalore, and his major research institute is working on this impact assessment of agricultural technologies and natural resource economics. So with that, I would like to invite Dr. Aditya for your lecture on impact analysis using PSM. So please carry on with your lecture.
Thank you, ma'am. Thank you for your introduction. Let me share my screen. Can you see my slides in the full screen?
Yes, sir. Yes, sir.
Okay, because I'm using two screens, I'm not sure. Thank you for confirming. Okay. Good evening to everyone, and nice to be here, and thank you for this opportunity to interact with you all, though on a virtual mode. So today's topic will be on propensity score matching. Before going into propensity score matching, I want to spend say 10 minutes on why do we need impact assessment methods in the first place? What are all the issues which makes necessary to have a separate set of methods to assess impact? And then I will talk about propensity score matching. And my focus here will be to make you understand the theoretical basis for matching, not just propensity score matching, but any kind of matching. Propensity score is one indicator, one variable which can be used for matching. There are different newer methods for that. So my focus will be more on the theoretical basis for it and do's and don'ts. So these are two very important things: when to use propensity score matching, what to do, and more importantly, what not to do. Okay. And if time permits, I'll show you how to do this in Stata. But I have done this before. The videos are there in YouTube or Facebook. I can also share you the codes and the data, and you can follow it up. So I'm not going to stress too much on hands-on, but if time permits, I'll do it. And also, I prefer to take the questions at the end, if you don't mind, because the questions that you're asking may be in the next slide. So if you don't mind, I'll take the questions at the end of my presentation. Feel free to post your questions in the chat or the question window. So let me start with theory of causal analysis. It is not a casual analysis, it is causal analysis. Many people called last 20 years in econometric research as causal inference revolution, because every day new methods have come up, or the changes to the old methods. Old methods are being questioned, new methods have been suggested, new measures have been suggested. There are so much discussions. Even this year's economic Nobel Prize goes to causal inference. So much happening in causal inference. But unfortunately, our econometrics teaching has not changed in line with what is developing in the econometrics. In our econometrics text, even in the advanced econometrics, we focus more on the time series, the panel data analysis, the usual suspects like how to identify multicollinearity, heteroscedasticity, and all those kind of things. But little is taught on causal inference. But if you look at the research publications which are coming out, most papers in one way or the other, they require some kind of causal analysis to answer those research questions which are taken. So we need to realign. I'm telling this to you specifically. I'm stressing this point because most of you are assistant professors, associate professors. You need to make certain changes in the curriculum and focus on causal inference, because when the students pass out, when the students actually enter the world of competitive job market, they need a solid background of causal inference. I'm not asking you to teach every method there is on causal inference. It will be a full course, but if you can just make the basics very clear to them, it will be such a great value addition. So what is this causal analysis and how is it related to impact assessment? All the methods of impact assessment, they have their roots in causal inference or theory of causal inference. So what is this? So theory of causal inference is concerned with first point, establishing the causation, and the second point, its magnitude. Between what? A cause and an effect. Okay. So I'll use this example throughout my lecture, which is you are talking about adoption of a particular technology, that is the cause, and you're talking about any welfare measure, which could be your income, which could be your food security, which could be anything. Okay. So your question or your methodological pursuit will be to answer the question whether adoption is causing the changes in the food security and by how much. If you answer these two questions, that is your impact assessment. It looks simple, but it is not. Let me tell you how. So it could be an intervention, it could be a technology, it could be a policy. Your objective is to measure how much beneficiaries are affected by the intervention you're talking about. So how do you do it? You have to compare the units which have received the treatment or in the intervention group with what would have happened in the absence of the treatment. So this is kind of real world versus an idealistic world. Okay. So many times in life also we think about these questions. What would have happened if I have not taken BSc Agri and I have chosen engineering, right? What would have happened, right? But there is an issue which I'll talk about it in later. So in order to have a credible impact assessment, we need to have a data exchangeability, which means even if you interchange the treatment and control, then the impact estimator should be the same. Okay. So let us try and start by defining impact. Many of you might think everyone knows impact. We have been working on this. What is the big deal in it? But if you define impact correctly, then half of the work is done. So as I told you before, impact is what would have happened in the absence of treatment for those units which are in the treatment. Let us go back to the agriculture example. Farmer has adopted a variety. If he has chosen not to adopt, then what would have been his income? When you compare the two, that is what impact is. Let us bring it to the notations. Expected value of yi given 1 minus expected value of yi 0. So expected value you can simply say as average. Y is your outcome variable, and subscript 1 and 0 indicates 1, it has got the treatment, 0, it has not got the treatment. So in essence, impact is the difference between mean of individual incomes or any outcome if they have received the treatment minus the mean value if they have not received the treatment. It is as simple as that. But the real problem comes here. You cannot observe yi1 and yi0 simultaneously. If a farmer has adopted the technology, what would have happened in the absence of technology, yi0 is not observed for the same period of time, same point of time. You can compare his previous year's yield, previous year's income, but over the 1 year period, everything has changed. That is the bias caused by time. For the same period of time, same point of time, you cannot have both treated and control observations for the unit. Here, what yi0 is there, this yi0 is called as a counterfactual, and this counterfactual outcome, this is counterfactual individual and this is the counterfactual outcome, it is not observed. I usually quote the example of cricket. Suppose I and Virat Kohli, just assume we both for a coaching class for cricket batting, and after 15 days you see how much runs I score and how much runs Virat Kohli score, and if you simply take the difference, then you would say, Virat Kohli didn't take any coaching, but he still scored more runs than Aditya, and coaching is useless. But this inference is wrong because you are comparing it to a wrong counterfactual. Ideal counterfactual would have been you have two Adityas who are very similar to each other. One goes to the coaching, other doesn't go to the coaching. Then if you compare, then it would have make sense. But where do you find two Adityas? It is not an experiment. Economists work in the field. You cannot have two exactly copies of a farmer, and you cannot give one person the treatment and one person the control and can compare. That's not going to work. So since the counterfactual is unobserved, we need to do all the circus that I'm going to talk to you in the next few slides. So what we do then, we take data from two separate groups. One is a treated group. Let us say you have data from 500 farmers who have adopted the technology. Then you take another 500 who did not adopted the technology. So we call it as treated group versus control group, or beneficiary group versus non-beneficiary group. And then we try to measure impact. In most of the papers, I should not say most, the number of papers now have reduced who do this. They simply compare adopters to non-adopters in descriptives. They say mean of adopted farmers is 10,000 rupees income, mean of non-adopters is 5,000, and they simply say that the impact is 5,000. That is wrong. Why it is wrong? Correlation is not causation. This is my tagline for the class. Correlation is not causation. If I want you to remember one phrase from my class, that is this. If you remember this, you're halfway through the principles of impact assessment. Let me give a very unique kind of example from the sci-fi world or Marvel Studio world. So assume that aliens from a different planet, they decide, let us go for a trip. Let us go around Earth and see what's happening there. So aliens are coming from a different planet to Earth. Just imagine, just assume. While ascending towards Earth, they see a Apollo hospital there. Okay, they have a look at the hospital, and to their surprise, they observe that most of the people in the hospital are sick. So that is the correlation. So they see a hospital and they see the sick people there, and they don't have any other information. And it is possible that aliens might make a conclusion that hospital makes people sick. So this is the danger of correlation and causation. If you assume correlation itself to be sufficient for causation, this is the kind of mistakes that you are going to make. And aliens might conclude that hospital is making people sick, and let us destroy all the hospitals and save humanity. Okay, this is one example. Second example, there is raining and people are holding umbrella. So this is correlation. And when people look at it from outside, they can make a conclusion that, by holding umbrella, you can make it rain, right? If you just observe the correlation, even this could happen. So correlation doesn't mean causation. And this is another, some funny kind of example. Everybody who went to space or moon has eaten chicken, but it doesn't mean that eating chicken will take you to moon. Same time, someone may say, whenever I sleep with my shoes, I'll get headache, and say that sleeping with shoes on gives you a headache. But there is third thing, which is causing both. He was sleeping with a shoe when he is drunk the last night. So it's actually the drinking which is giving his hangovers and headaches, and not sleeping with shoes. So if you simply observe correlation, these things can happen, because one, it could be simply nonsense correlation, or it could be a third factor which is common for both, which is causing these two things to correlate. So correlation doesn't mean causation. Let us come back to the word of agriculture economics. Adopters of a technology might have higher incomes. When you say that, when you tabulate the mean values of adopters and non-adopters and tell me that adopters have a higher income, I do agree. That is correct. But it is simply correlation, and it is not sufficient to establish the causation. You need to do more things to establish causation. Why? Because I'm not denying that there is a difference in income. I'm completely in line with you that there is a difference in income. There is a difference in income. But I have a problem when you say that this 5,000 rupees is only due to adoption. That is where the issue is. For instance, another example I'm quoting, marriage in church has a high correlation with unnatural deaths, maybe suicides. But you cannot claim that church is causing unnatural deaths. Sunglasses sales, highly correlated with ice creams. No, both are caused by the third factor, which is sunshine. Lack of correlation doesn't mean lack of causation. This is another important thing. So when a ship is sailing, okay, the sailor actually moves the rudder to the right, sometimes to the left, okay, depending on where the wind is blowing and which direction he wants to go. But assume you are looking at from the top, and you're not see you just see the rudder is moving to this left, to the right, to this left, right, but ship is moving in a straight line. You might think that there is no correlation between how is moving rudder and the ship is going. You might say that there is no causation here, but there is actually a causation. Okay. So two things: lack of correlation doesn't mean lack of causation. Presence of correlation is not sufficient to say that there is causation. Let us further conceptualize the impact assessment. So this part we have already done. We are taking one group from the treated, one group from the control. Let us expand the notations. I remember that I have not explained to you why I have a problem when you say that this 5,000 rupees increase in income is only due to the adoption. I'll come to that. Okay, but let us expand our notations a bit. Initially, we said that expected value of yi1 minus expected value of yi0 is impact. But expected value of yi0 not observed. So we are expanding it to groups. Now we have, say, 500 persons in the treated group, 500 persons in the control group. And now we are taking a difference. Now what happens? Expected value of yi1 given t is equals to 1. Expected value of yi0 given t is equals to 1. What does that t indicates? T indicates again groups. But closely observe here. Closely observe here. yi0 given t is equals to 1 is not observed, which means what happened if everyone in the treated group were not to be in the treated group? It's not possible. Everyone in the treated group have already adopted. They're already beneficiaries. You don't know what would have happened in the absence of the treatment. So the second part, the counterfactual outcome part, is still not observed. So what we do, we calculate impact at, or you can say estimate of impact, whatever you want to call it. So expected value of yi1 given t is equals to 1 minus expected value of yi0 given t is equals to 0. What is the difference between this last term here versus the last term here? Okay, what is the difference between these two things. The difference is that we wanted what would have happened for the treated units had they not adopted. Since it was not observed, we are taking a proxy, we are taking from the control group, and they have anyhow not adopted. So we are estimating impact, assuming that these two are similar. As long as expected value of yi0 given t is equals to 1 is similar or close to expected value of yi0 given t is equals to 0, bias is 0. Let me put the same thing in very normal language. Okay. In the absence of the treatment, assume that there is no treatment now. You have 500 adopters and 500 in the control group, and you remove the adoption out. You're removing that variety out. Okay. In the absence of the treatment, your treatment group and control group should be exactly similar to each other. If this one condition is met, there is no need of any impact assessment methods. You can simply take a difference between the mean value of income from the treatment group and mean value of the outcome in the control group and say that with confidence that this is impact. But think through a bit. Think through a bit. Will this ever happen in real situation? In what circumstances the treatment group and control group would be exactly similar in the absence of treatment? Only if they are similar with respect to all other characteristics. What are all other characteristics that we are talking about? Expected, or let us not use the expectations here. I don't want to confuse. Let us say mean age, on an average education. So let us say all the variables that I'm talking about, it is on an average. I'm not specifically saying in treated group there is one person who has like a PhD and in control group there is no PhD. I'm least bothered about individual observations. I'm talking about on an average when you take the average for both the groups. So let us say the treated group and control group are there, and the only difference between the two groups has to be your treatment. Except the variety adoption, there should be nothing, absolutely nothing, which differentiates the two groups. But what happens in the adoption of agriculture technologies? Let us go back to your theory of adoption from extension or innovators and laggards, that concept, adoption of innovation or diffusion of innovation. Usually the adopter category is dominated by those farmers who are better educated, motivated, better extension contact, better social network, better access to finance, right? So they are more likely to be in the adopter category. And who are in the control category? The opposites. I'm not making a claim that every educated farmer will be in the treatment group or every uneducated farmer in the control group. I'm talking about the averages. On an average, treatment group is dominated by better farmers, if you can generalize, and control group is dominated by laggards. When you make a simple comparison between the two, I agree there is difference in income, but you don't know if the change in income is due to the technology. Is it due to the education? Is it due to the finance? Is it due to some other axis? Is it due to the extension contact? When you don't know what is causing that, then it is not impact, and this is not impact assessment. So this is where all problems of impact assessment using observational data. If you can do an experiment, how do agronomists do an experiment? He will have nitrogen trials. For example, he will have 6 plots, and in each plot he varies the nitrogen, but what he do next? He keeps everything else constant because he wants to make sure that Only the difference between the different treatments has to be the treatment only. If you do weeding in the first plot, he will do weeding in all other, right? But as an economist, can we do that? Yes, you can do RCT, randomized control trials, but it requires a lot of money, lot of efforts, and lot of time, which most of us cannot afford. When we want to do impact assessment from observational data, we need to encounter this challenge to make it a credible impact assessment. What is that challenge? To make sure that your treatment group and the control group are comparable. To make sure your control group is a proper counterfactual. To make sure your treatment group and control group are exactly similar except for the treatment. If this happens, then there is data exchangeability. I'll skip this. And now let me come back to propensity score matching. Before coming here, propensity score matching, let me take a minute to tell you why using regression as against descriptive still do not address the same issue. If you read the econometric text carefully, regression is again a fancy way of averaging. So even when you try to do regression and use a dummy variable and try to control for all these variables, their first issue is the dummy variable, the treatment variable that you're talking about, it is endogenous, econometrically speaking. Why is it endogenous? Your treatment variable or adoption variable is caused by or is affected by education, motivation, extension contact, and other things. So that treatment variable is endogenous. If it is endogenous, the correlation between that variable and the error term is not zero. If that is not zero, it will lead to bias. The problem here is you don't know the sign of the variable, the sign of the impact that you are estimating through general regression. You don't know whether it is overestimate or underestimate. When these two things are not known, the extent of bias is not known. It is garbage in and garbage out. Literally, you achieve nothing by doing this. You could say that I'm controlling for those variables. Controlling for those variables will not help you with endogeneity. It will not help you with the selection bias and the specification bias. Why we call it as a specification bias? Because people with certain characteristics, people who are educated and better motivated, they are self-selecting themselves in the treatment group. That is called selection bias. And this also leads to specification bias because you are not accounting for the selection process in your regression. So simple regression won't work. Descriptives don't work. You need some methods if you want to use, if you want to estimate the impact. So let us talk about confounders a bit. Excuse me. So let me go back to the same example, and I'll be using this example throughout. Education and motivation. Okay. The first hypothesis is that education and motivation, they affect net income, right? So educated farmers, even without the adoption of that specific variety, they may be doing many other things correct. They may be using proper dose of fertilizers. They may be timing their application correctly. They may be looking after the plots better. They may be maintaining the soil fertility better. Many of these things you cannot account for in your limited number of variables that you have. Even without a variety, educated farmers will have a higher income. So there is an arrow which is in this direction, which is affecting net income. Then you are talking about adoption causing net income. this is what you want to measure. This is the entire circus that we are doing, is to quantify this arrow. First, to establish whether there is an arrow like this, whether adoption is causing net income. Second question is by how much. But the education is also causing adoption. Motivation is also causing adoption. So better educated and better motivated farmers are in adoption. So there are two channels here. One goes education to adoption, adoption to net income. There is education directly to net income. Okay. So in econometric text, if you look at this is called as front door, and these two are called as back door. If you open any recent books on impact assessment, I'll highlight two such books at the end of my presentation. You will hear a lot about front door and back door. So front door is what you want to estimate, and in order to do that, you need to close back door. That is the term that they use. I'm using the same terminology because I want you to be aware of those terminologies, because when you read those texts, you should be able to understand. So here, these are called as confounders. The definition of confounder is those variables which have a link to the treatment variable. Adoption is our treatment variable, as well as our outcome variable, that is net income. So these are two such variables, and we need to close these back doors if you want to estimate the front door. Otherwise, this will be biased. So how do you close this back door? That is the challenge which most of impact assessment methods try to address. So impact of technology adoption. Let us continue with the same problem. For simplicity, let us assume that there are 7 farmers each in adopter and non-adopter category. You cannot do impact assessment with just 14. I'm trying to make it clear about the concept that we are talking about. So this is adopter, and I'm talking about just one variable, and this is non-adopter. Just have a look at both. I want you to have a look at the mean values here and the mean values here. What you can observe. So you can simply say that adopters, they are better educated. Non-adopters, the mean level of education is less. Again, I'm stressing this point. I have no business of comparing individual units here at this point of time. I'm more worried about the mean values, the overall average. Okay. In impact assessment, say that on an average is a very common terminology that we use. And this is not necessarily true in every case. You might come and argue that I have a case where adopters are better educated than non-adopters. It's perfectly possible. But for the explanation here, how the problem can arise and how we can overcome that, I'm taking this hypothetical case where adopter farmers are better educated, non-adopters, they have less mean education. Now, if you simply compare the income of these two groups, what is the problem? Remember this, you will not be able to say whether the difference is attributed to the adoption or is it due to the education. This is you are not sure about. What if we can match? This is what Rubin and others thought when they devised this method of propensity score matching. Let us match the units which is closest in terms of education. Here we are going to the individual units. So let us see how does it go. The first unit, okay, the first unit, it has an education of 10 years. And who is the closest match here? It is D. He also has 10 units. So first matched pair is 1 and D. For the second unit, we have G here. It is not exactly the same, but is close enough, right? So for similarly, you can go ahead and match each unit with the closest unit possible. It is not necessarily that every unit will have a matching pair in the non-adapter category, which is called as lack of overlap, which or lack of common support, which I address in the next question. But theoretically speaking, it makes sense. You were saying you cannot compare the two groups because there is difference in education as well as difference in adoption. And when you take the difference, you are not sure whether the difference in income is due to education or due to adoption. But what if in the matched pair, you take the difference in income? So they both have same years of education, and only difference between them is whether they're adopters and non-adopters. Assuming all other variables except education are same across two, which is another difficulty which we address later. But assuming just one variable, it makes sense. So you can simply take the difference between 1 and D with respect to income, and the only difference between these two is adoption. So it has to be adoption is causing the difference in income. You take the difference for all and then sum it, then take the average. That becomes your estimate for impact. Very easy, right? Very easy. Now, let us add another confounder. Let us add another variable. I have added land here. Again, I want you to look at the mean values here and here. What you can see here. So adopters on an average are bigger farmers, large farmers, those who have better resources, but non-adopters here, they are small farms. Right. Now, can we match? If you take education, 1 is pairing well with D, which we have already seen in last slide. But if you take land, first unit has 4 hectares of land, and his earlier match D has just 2 hectares. So he's not a good match. For 1, the proper match is C. Now, here is the problem, right? This is called as curse of dimensionality. Okay, curse of dimensionality. When you add more variables, you have added just 2 here, remember. And in real problems that we are going to solve in real observational studies, there could be 20. Imagine the permutations and combinations that you have. When you try to match with respect to many variables, matching becomes extremely challenging and extremely difficult. So you cannot match. So theoretically, matching is good, but practically, when you add more number of variables, matching becomes difficult. So this is what I told you, curse of dimensionality. So intelligently, they came up with a solution to this, which is called as propensity score matching. Excuse me for a second. My throat is drying up. Okay. This is called as quasi experiment. I have seen many people arguing what is a quasi experiment. So I want to spend a minute here to tell you what is a quasi experiment. Quasi experiment is not a real experiment, but still an experiment. Okay. So what do you mean? It means you're not doing an experiment in the field. You're collecting the data as it is. You're collecting observational data. And when you bring it to your lab, when you bring the data into your system, when you digitize that data, and within that data, you're doing some experiment. What is that experiment? You are trying to match similar units and then check the difference. So this matching is trying to mimic a real experiment that you would have done in the field. So that is why all those methods which have some kind of rearranging stuff, they are called as quasi experiments. You're trying to mimic a real ground scenario. So the theory is same. What I detailed you in the last slide, the theory is same. The whole exercise is to match the treated units with the most similar control unit. How you are going to do? Different story. Which variable you are going to take? Different story. How many variables? We will understand that later. But basic in its skeleton form, what we are talking is you are trying to match two similar units, then trying to take a difference. That's it. So propensity score. It is a natural weighing scheme to achieve matching. And note this sentence, it combines the information on many covariates into one and thus helps to overcome curse of dimensionality. If you remember what is curse of dimensionality, the problem was you cannot match with respect to 10 covariates. For with respect to first variable, A is matching with D. With respect to second variable, A is matching with C. For third variable, A is matching with F. You cannot match. Literally, you cannot match. How do you identify that one unit from the control which is closest to one unit in the treatment based on 20-25 observed variables? To do that, the simplest way is to condense all the information from those 20 variables into one single variable. And based on the assumption that if two units are similar with respect to that one variable, they are likely to be similar with respect to all those 20 variables. If we can, and remember, this is again not on individual basis. There could be difference between A and D, though they are matched. But when you take on an average, the treated and control, when you do this reweighing, they are similar on an average. So the problem is solved if you can identify one such variable which condenses the information from 20 different covariates. And that one variable is called propensity score. I want to stress here, there are different matching methods. Propensity score matching is one matching method which uses propensity score for matching. Okay. There is quotient exact matching. There is Mahalanobis distance matching. There are other different matches which I'll briefly touch upon. So if you use propensity score for the purpose of matching, it becomes propensity score matching. So what is this propensity score and how it is going to combine the information from those 20 covariates? So it is the probability of the unit being in the treated group conditional upon the observed covariates used in the estimation. In your simplest definition, propensity score is the estimated probability. Assume that you are doing a probit regression. Okay. When do you do a probit or logit regression? When your dependent variable is a dummy variable. Which is the dummy variable here? It is adoption or beneficiary, or in a general sense, the treatment variable. Your treatment variable is dummy, 1 for adopter, 0 for non-adopter. So when you take that as your dependent variable and run a regression, okay, so you get probability hat, p hat, and that p hat is the propensity score. Why is it called propensity score? It indicates the probability of a treated unit being in the treated unit subjected to all the covariates that I have used in the estimation. Okay, this is, I'm using bit of econometric, forget it. Selection equation, why it is called as a selection equation? These covariates and this specification determines who is in the treated and who is in the control. You run that model and expected value of PI is the propensity score. And it ranges from 0 to 1, and this is used as a basis for matching. how do you make sure that propensity score is correct? We will come to it in a second. Before that, I want you to carefully understand what are the assumptions that PSM use. PSM is a very controversial subject in econometrics literature. There is certain group of people who say PSM is very good. There are some people who literally hate propensity score matching. They say it's not a good method. If you understand and want to be the part of that debate, most importantly, you should understand the assumptions part. Conditional independence assumption. Okay, it's called CIA. There exists X set of covariates. Once you account for those covariates, potential outcomes are independent of treatment status. What it is saying is, you take 20 variables to estimate the propensity score. Once you estimate the propensity score and match, after matching, there is nothing which differentiates between the treated and the control. Okay, this is what the assumption says. But conditional independence assumption is very difficult to test. Why? Because you don't know all the covariates which would potentially determine the adoption. Even if you talk about adoption, you can say all these different kinds of words. You can say that the farmer who has more IQ, he will adopt more. I will come and say the farmer whoever farmer who has a better risk-taking ability, he will adopt. Someone else and will come, he will say the farmer who has less stress hormone will adopt. Someone else will come and say some fancy other word. They say this variable will also affect the treatment or control. Can you measure each and every one of those? No. There are only set of observable variables which you can control. There is a set of unobservables. If those unobservables starts to affect the treatment allocation, if unobservable confounders are there, this method fails and this assumption cannot be tested. This is the major controversy. Okay. In other words, after matching, the treatment allocation is as good as random. That is self-explanatory. And this is also called as selection of observables. We can adjust T only based on observable covariates. That's what I'm saying. If you have unobservables, which also affect treatment participation, we cannot control for them. That is called as unobserved confounders. That is called as hidden bias, whatever you want to call it. Second assumption is called common support. Let us go back to what we have been talking. Our hypothesis is that if you can match similar unit from treated and control, they will be similar. Once we do this, we can simply take the difference between the outcomes in the two groups. But in order to find a similar unit, there should be a similar unit existing in the control, right? If say the treated unit is all excellent, like very good farmers, and the control units is all very poor farmers, then there is no one to compare. How can you compare if there is no overlapping? Some good farmers should be in control, some bad farmers should be in. I'm using a very generic language. Forgive me for that. Take an example of a cricket team. You want to identify closest match between two teams. For example, in India team, Virat Kohli is playing, and in the opponent team, they are playing against a list A team. There is no one like Kohli, with whom you will match. The assumption is correct. If there is a AB de Villiers in the other team, you could match, but there is no ABD there. Okay, so there is no one to match in the control. So the common support assumption is violated. How do you test it? Once you calculate the propensity score, you go for a density scores, and you should check for the overlapping. You look at this entire region for every unit in the treated. For example, the treated units. So this is for treated units, and somebody is here. Okay, somebody is here. So from the control also in the same region, there is someone. But come here, the propensity score is almost 0.8, okay, at this region. And from the control, there is no one beyond 0.6 control. Okay, from the control group, there is no one beyond 0.6 propensity score. So with whom you are going to compare this? No one. So if there is no common support, there is no meaning in using propensity score. This is the case of poor balancing. So in this region, there is no treated units, and this region, there is no control units. So the overlapping is only in this region, right? Examine this. Suppose somebody is here. So this is the treated unit. There is someone here also. In the entire region, there is someone to match. There is someone here. There is also someone to match. There is here. There is also someone to match. In every region, you have someone to match. Then you say that there is good common support. Okay. So range of propensity score is between 0.01 to 0.5, and the dotted is for most units in the treated. There are units in the control. For every ABD Villiers, there is a Virat Kohli in the other group. You are sorted. It's this assumption is satisfied. This is one of those assumptions which is easier to test. Okay. Let us now bring all those bits and pieces that we have discussed and bring it into the methodology now. Now you have understood why we need to match. Then we understood curse of dimensionality. Then the solution for that curse is propensity score. Now how we are going to do it in practical. So first is selection equation from which you want to estimate the propensity score. What is the selection equation again? The dummy variable for adoption or beneficiary or whatever you want to call it, you are going to take it as your dependent variable, and you are going to take all the covariates as the explanatory variables, and then you are going to run a probit or a logit regression. Okay, logit probit. If it is a multi-value treatment, it's multinomial probit. Key question, the $1,000,000 question: which variable should you use? My supervisor always said as kitchen sink regression. So whatever is left over in the kitchen, it goes to the sink, right? Most people do regression like that. They have collected age, education, all this, the contact in cooperative society, they have contact in this, contact in that. They take every possible variable and include it in a regression. But it should not be a kitchen sink regression, and you should have a justification why we are using that variable in the selection equation. In propensity score matching, most referees, when you send it to a journal, they will ask this question: why this variable is here? So your justification has to be why you think that variable will have an effect on the selection equation. In the common terminology, why that variable, according to you or according to literature, is important in determining whether a farmer adopts a technology or not. Let me give an example. Extension contact. You can say that literature shows that farmers who have better extension contact will have a better information. They will come to know about the technology first, and they are more likely to adopt. Done. Same way, you have to give justification for every variable that you have. You should include all those confounders. Let me quickly tell you what is confounder. Confounder is that which affects both the outcome as well as the selection. Second step. So first step, what we did a probit regression. Dependent variable is treatment, and you run a regression. Once you run a regression, you calculate the probability hat. That probability hat or y hat, whatever you want to call, from the probit regression is your propensity score. Once you have a propensity score, you need to check the basic premise. You need to check whether your propensity scores are good enough for matching before you go ahead and start matching. excuse me. Okay, how do you do it? First thing is region of common support. You're going to plot the density of the propensity score distribution for treated units and the control unit be sufficient overlap between the two. If there is no common support, either the problem is there with the data set, you're taking two groups which are totally uncomparable, you cannot do propensity score matching, or your specification is not very good, recheck your specification. Specification means here which variable you are using. You could be leaving out some important variables. More important, we need to test for balancing. Okay, balancing is the most important part of doing a PSM. If you want to do PSM estimating propensity score, no big deal. Common support, usually we get common support. Reasonable common support we usually get. Balancing, not always. Everybody is not lucky to get a proper balancing. So what the hell is this balancing? Why we need to do this? Let us go back and think about what was the single most important philosophy that we are using here. The philosophy that we are using is, if two units have similar propensity scores, they are also similar with respect to the covariates or the variables that we have used for creating the propensity score. This is the basics, right? We wanted to match with respect to 10 variables. We couldn't do matching because of curse of dimensionality. Then we said propensity score combines the information on all those 10 variables. Now we say that same propensity score means similar values for all those 20 variables across two groups. If I am matched with someone, say X, because we have same propensity score, we should have same age, same education, same this, which are used for calculation of the propensity score. But how to test this? I'm going back to the same example because visualizing balancing is very challenging. When I started to explain this, people used to get confused. So that's why I'm trying to give a visual representation to it. Initially, we started with adopter, non-adopter. We started with education and land. Now we have calculated the propensity scores, okay, for both adopter and non-adopters. How we calculated propensity score? With a probability regression. Now what we have done here, we have arranged in ascending order of the propensity score. The 6th unit has least propensity score, 7th unit has highest propensity score. We arranged both adopters and non-adopters. We have simply sorted it. Now look at this. This is called as strata. In the first strata, the 3 units here and the 3 units here, and they are in the range of 0.38 to 0.48 propensity score. Within this strata, there are 3 units each, and the range of propensity score is almost similar. On an average, you can say the propensity scores are very close. How many strata do you want to have? There are algorithms to work out that. You need not to worry about it. But the simple thing is, within each strata, the propensity scores are very close. In the second strata, there are 3 units here, 2 units here in the range of 0.5 to 0.7 propensity score. Okay. So what is the important take home from this? In each strata, propensity scores are similar. Okay. This is out of common support. There is no one here with that range. So what we do is we do a t-test within each strata across adopters and non-adopters. I'm repeating for the sake of clarity, pardon me for that. In both treated and control groups within a given strata, propensity score is very, very similar. It's between 0.45 to 0.55. They have similar propensity scores. And then we do a t-test between those 2 units to see if other characters are similar between these two. If our hypothesis is true, if our assumption is true, that same propensity score means same observable characters, then this t-test should not be significant. If the t-test turns out to be significant, then we say that though they have same propensity scores, the age is not same, the education is not same. So then there is no meaning of matching. The two matched units have different characteristics. You wanted to match similar units, so your propensity score is not working. Your propensity score is not working. Okay. So if this happens, you need to go back to the specification. I'll come to that next. So now, what are the things you have done? You have calculated the propensity score. You have checked the common support. You have done the balancing test. How did we do balancing test? In a matched strata, you checked adopters and non-adopters, did a t-test for age, education, and all other confounders. If propensity score is same, age should be same across two groups, education should be same. If it turns out to be significant, then you are in trouble. You don't have balancing. If you don't have balancing, you should go back to the model specification. This is your second major disadvantage of propensity score matching. You don't have a specific guidelines on how to achieve balancing. Here, they say you can add cross products, you can try with different quadratic variables, square terms, interactions, and different things, but there is no specific guidelines which tells you how to get balancing. So this has been a biggest problem with propensity scores. I hope I'm not forgetting anything. Okay. So next step. Now you have propensity score, you have established that propensity scores are good. Now you have to match. What is the criteria you are using to match? That is where this problem comes. What do you mean by criteria? You know with respect to what you are matching. You want to match with respect to propensity score. But how do you match? How do you define nearest? How do you define closest? That criteria comes here. One very commonly used method is nearest neighbor matching. So there is NN1, there is NN3, and there is NN5. I assume that you don't need an explanation for this term. It is nearest neighbor means for a treated unit which has a specific propensity score 0.6, you need to find someone else from the control group who is nearest with respect to propensity score, closest. For example, if I'm 0.65, my propensity score is 0.65, from the control group, you find someone who is 0.64, 0.66, 0.67. If you just find one unit from the control group, it becomes NN1. If you find 3 units, it becomes NN3. If you take 5 units, it becomes NN5. Okay. This is called as in and out matching. If it is matching this criteria, it comes in. If it is not matching, it goes out. The problem with nearest neighbor matching, you don't know, he is my neighbor, but you don't know how close he is to me. I'm from Karnataka, and I'm from a region called as Malnadu or Western Ghats region. In Western Ghats region, my nearest neighbor to my home is 5 kilometers away. You cannot literally call him as neighbor. Similarly, for a unit in propensity score matching, the propensity score could be 0.6, but the nearest match is 0.9. If you are matching 0.6 to 0.9, you cannot be sure that they will be similar. So you need to think closely on this. Next is called as caliper matching. So again, just like nearest neighbor matching, here we are defining a caliper. Caliper is kind of a bandwidth. If I'm in a treated unit and my propensity score is 0.65, you want to take my nearest neighbor within the vicinity of 0.05. 0.05 plus, 0.05 minus. If there are no units, out of common support, you go out. That is caliper matching. Then there is stratification matching. I told you earlier, the strata arranges in terms of stratas. Within strata, you take everyone and then match. Then there is kernel matching or local linear matching. This is called as weights-based matching. Here, you do not try to match individual units. Here, you try to give regression weights, and based on the weights, every unit gets some value, and similar units gets higher weightage, and those which do not have a comparable match, they get lesser weight. And when you do the regression, it automatically controls for selection. Let me tell you, this method is more popular these days. Most people prefer to use this method. In the selection of methods, this could be a advanced topic, but many of you might have already heard me speaking about this. So I want you to get something new from my session. The important thing here, there is a trade-off between bias and variance. If you think I'm going to match just one unit, NN1, then it is possible that you could get a very close match, a very good match. So when you get a very good match, bias will be less. But what happens to the variance? You are matching with just one. It could be an outlier. It could be someone which is, there could be a lot of sampling variance. So variance shoots up. You are trying to reduce the bias and variance shoots up. You are trying to bring a lot more observations to matching in stratification matching, but while trying to bring more variables and reducing the variance, you are in a way increasing the bias. So there is a kind of trade-off between the two. The intelligent way economists these days use, they take all these matchings, they do all this matching and give a table. Nearest neighbor 1, this is the impact. Nearest neighbor 3, this is the impact. Nearest neighbor 5, this is the impact. And they try to show that estimator is robust to the matching method in order to say that our matching methods are good. Some people, they even take the average of all these matching estimators and try to control for the problem of bias and variance that we are having. But remember, weights-based matching is the new normal or the more popular way of doing it. This is, I already explained it to you. Once you match, okay, once you match, then it's simple. You take the difference between the matched pair, then take the average of that, then that is your impact. Here, that is called as ATT, average treatment effect on the treated, which means to say that what would have happened if those treated units were not to adopt the technology. As we defined it earlier, that is what impact is. What you should look for? You should look for the difference. It is minus 0.011 and it is not significant. You can also check it with standard errors or t-stat. It is not significant. If it were to be significant, how do you interpret? You will simply say that the impact of the technology that I'm looking at, in this case, because of SHG participation, the household expenditure reduced by this many dollars, this many rupees, whatever units in which you are measuring. People often ask, which is the unit to interpret the result? In whatever units you have measured the outcome variable. Here the outcome variable is household per capita expenditure in Bangladeshi Taka. That's the currency. I hope I'm pronouncing it correctly. In whatever units you have measured your outcome variable, in the same units you are going to interpret. I'll come to the more nuances. Okay. Few other issues. First, the regular standard error that you are using, it is no longer valid. You might ask, where do I need a standard error here? You need standard error because you want to know whether the treatment effect is significant or not. But the regular standard error is not valid because within the sample, you're doing another sampling. You're cherry picking the control units and doing this. So one common way of estimating the standard errors in that case is called bootstrapping. In bootstrapping, we take 50 or 100 or 1000 repeated sample from our sample and estimate the standard errors and then average it. I may not be very precise in the statistical language, but this is what bootstrapping is. So caliper matching has lost its shine. I don't want to talk about it, but the important aspect is sensitivity analysis. Earlier, I have highlighted that one issue of propensity score is hidden bias, or the assumption that this is matching on observables. So unobserved confounders still can cause a lot of problems. So in the sensitivity analysis, what we do is, so this is the size of impact. The impact is 10,000 rupees. But if there are some other variables which you have not included, that variable could be anything, will my estimate remain credible? So you estimate the delta level. Delta level is called as hidden bias, level of hidden bias, and a common way of doing is Rosenbaum bounds. So you just estimate it and give the results in appendix. But this is a must. This is a most important robustness check. I'll come back to the major limitations. First, very, very difficult to test the basic assumptions. Whenever a model has too many assumptions and the assumptions are impossible to test, you are correct to doubt that method. So that is what econometricians are saying about PSM. I just remember a quote which says, all methods are basically wrong, but some methods are useful. Every method has its own limitation, but as a user of that method, you should be aware about the limitations as well. You should not go and claim that this is the impact. There is certainly no doubt that this is the impact. You can never do that. So you be humble and know the limitations of the method that you're using. I already talked about hidden bias or bias due to unobservables. I'm not very good at explaining this. Actually, econometrician says that PSM mimics CRD design, whereas RCBD is more efficient, and coarsened exact matching and other matching methods mimics RCBD, which is more efficient than PSM. You may be better than me in understanding the paper, so I suggest everyone to read why propensity score should not be used for matching by Gary King. There are some papers in 2012, 2018, 2019. They are available if you just Google it. Next, the limitation is sometimes we call this entire process as black magic. You don't know how to achieve balancing. You really don't know. If you get balancing, you will be happy out of the world. But if you don't get the balancing correct, it's going to be a problem, and you don't know how to get the balancing correct. And the most important one, please do not use this with small samples. I keep saying many studies which use propensity score matching when you have samples like 200, 150. I perfectly understand the concern. I perfectly understand that for a PhD student, it's not easy to get 500, 600,000 samples. But your methodology doesn't understand. Your methodology doesn't understand that limitation. So rather than making a blunder, go for methodologies which can do well with small samples. Even people are saying for good propensity score matching, even the 1,500, 2,000 sample is must. I'm not going to that extreme, but at least 600 to 700 sample is must if you want to go for propensity score matching. Even if you get balancing correct, even if you get everything else correct, you still should not use this because it's a semi-parametric method. You will never know what's going behind. You cannot visualize everything. So please do not use with small samples. This brings to another topic. You may be wondering, we have called this guy to talk about propensity score matching. Instead of convincing us to use propensity score matching, he is diverting it and he is saying more criticisms about the method. I'm doing that because it is very important to understand PSM. Let me tell you this. Whenever I go for different training programs, I insist the persons that first session on impact assessment should be PSM. Then all other impact assessments should come, because understanding propensity score matching is basic for other impact assessment methods. But what are the better methods? What are the better methods? So there are two ways to use propensity score. One which I have highlighted is as a matching variable, and the second is the regression weight. This method, my friends, is the method which is gaining lot of traction in econometrics. So that is called as IPWRA. It's a bit of mouthful, but it's a very good method. It is called as inverse probability weighted regression adjustment, IPWRA. Okay, because if you don't have astronomically large data, matching will not work. So it is better to use as a regression weight, and that is what IPWRA tries to do. It is called as doubly robust method. So it is a combination of two methods. It is there is a regression adjustment, not the regular regression. Regression adjustment is another method, and there is inverse probability weights. So when you combine these two, it is IPWRA. So there are two equations. One is a regression adjustment equation, and another one is the estimation of propensity score. Even if you get one of these estimations correct, then still your estimate will be unbiased. I should not say unbiased, but bias will be minimized. I would never trust someone who says that bias is zero. That's literally impossible to achieve. Other matching methods, there are quite a few. Coarsen exact matching by Barry King. Few months back, I was one of the strongest proponents of coarsen exact matching, but now, unfortunately for me, many research papers have come criticizing coarsen exact matching. Even the title of the one of the paper is, should coarsen exact matching be ever used for impact assessment? They go to the extent that this is not a method suitable for impact assessment until you have what we call as big data, millions of data points. If you have, you can go for coarsen exact matching, otherwise you should not. In fact, I have used this for one of my papers, but now that paper is orphan. I have to find a different methodology for that. One of the oldest matching method, Mahalanobis matching. I think you are better than me in stats, so you don't want me to explain what is Mahalanobis distance. Instead of using propensity score, it uses Mahalanobis distance. Then this is the new entrant. This is called entropy balancing. If someone wants to really work on impact assessment and in matching methods, and if you are not going towards instrumental variables or RCT, this is the method to learn, entropy balancing. This has very attractive properties, does reasonably well even in samples less than 1,000. A very good method to learn. I don't want to stress too much on the advantages, but the basic one is it doesn't need a panel. It has fewer constraints as it's the semi-parametric, and observed confounders. If there are effects, self-selection can be minimized. But the biggest advantage is one of the simple methods, easy to understand. You can understand the philosophy that's behind this method. This is important. These are the two resources that each of you should be aware of. One is called as the effect by one of the persons that I admire the most, Nick. So he has written a book called The Effect. You can order your hard copy, but the soft copy is available online for free, and the address is theeffectbook.net. You can see here the effect.book.net. I can share you the links also. You can simply type the effect book. You will get every method he has described in detail, and you will get R code, you will get Stata code, you will get the data sets, you will get the Python codes, whatever you want, you will get it. And this is the most advanced discussion on impact assessment. Second, another favorite of mine, I have done 2 courses with him, Scott Cunningham, the brilliant Scott Cunningham. Same logic, you can get the book online, and you can also order your hard copy. So here also Stata, R, and Python, all 3 codes are available, and the data set is available. So you can, these are the 2 things that you must have. And this is selected readings. I'll share my slides to ma'am. You can always have a look at that. I'll stop here to take questions first. And thank you for bearing with me for so long.
Thank you, sir, for your presentation. And there is some question.
Propensity score really better than multivariate analysis?
Multivariate analysis.
Yeah, this is a very subjective question. I do not have a specific answer that yes, this is the best method, but looking at your data, if you think that observables are the major things, major confounders, and you have a sufficient sample, propensity score matching is a very good method. But if you are not sure about many things, if you are not getting balancing, and your data is small, I do not say that PSM is a better method. And multivariate analysis is a very broad term. If you ask me to compare a specific impact assessment method, then I'll be able to answer clearly. But unfortunately, there is no straightforward answer for that.
So there's no
Anyone
other
wants to ask question?
So if anyone want to ask, then
How to eliminate the backdoor effects? Yeah. So backdoor is when you have confounders. Backdoor is when in your treated group, you have some other variables which are also different across treated and control. So if you go back to propensity score matching, what we are doing is we are doing a matching. And when you do matching, so automatically there is no difference in education. So that education backdoor is closed. There is no difference in terms of motivation. If you could include motivation as a variable, I don't know how do you construct motivation. But if you can take all those variables and include it in your matching and then match, your backdoors are closed. I'm not saying this is the only way to close backdoors. Backdoors can be closed by using instrumental variables. Instrumental variables are those variables which are like exogenous and they affect your treatment, that kind of thing. So even if you have a good instrumental variable, then also you can close the backdoors. Yeah. They doubt regarding assessing climate impact with respect to crops, animals. I think you can get in touch with me. It would be very difficult to explain that broad concept here, I think. Any more questions? I'll be happy to check. In what way PSM is better? Okay, yeah, please go ahead.
Hello, sir.
Yeah.
Sir, in one paper I have seen that they have applied statistical test like t-test, f-test to see differences after getting PSM score. So can we do like that?
What t-test they are doing after getting propensity score is called as balancing test. I already explained to you, once you get the propensity score, you should check for balancing. There are different ways of doing a balancing test. And if I remember correctly, in a Stata command, there is an option that after you match, it will estimate bias before and bias after, and it will give you t-test score and f-test statistics. That is again another way of doing balancing property. You can do any of the balancing tests that is available. You need not to give the table. Some people do, but it is not necessarily that you provide all f statistics and t statistics. You could include it in appendix or something, but it is a part of balancing test. Yeah.
Okay, so they didn't do any regression analysis, only after balancing that paper means it was there.
No, we don't do regression in propensity score matching. You calculate a propensity score with regression, but once you do the matching, you simply take the difference and average it out. So you don't
Okay.
have a regression once you calculate the propensity score. There is no regression.
Acha, acha, okay, okay.
Yeah.
Okay, thank you.
In what way PSM is better than other impact assessment methods like economic surplus and partial budgeting? This takes me back to my original question or my starting slides. First of all, economic surplus, again, too many assumptions, and it is a kind of macroeconomic thing. I don't want to talk about economic surplus here. The major issue is with elasticities. You don't have elasticities for crop, that particular region. Elasticities are questionable. I don't want to discuss about economic surplus, but partial budgeting I will talk about. In partial budgeting, you take the mean values of the treated, mean values of the control, and then you say added cost, added returns, and everything else. But the main issue is when you take the mean of the treated units, the treated farmers are better farmers, and the control farmers are usually the other way around. So there are many other things which are different across these two groups. Their education may be different. There are many things which are different. You cannot cherry pick those with same characteristics. That is not possible. When you go for random sampling, you will get different units. So in that case, when you get the difference in outcome, you cannot confidently say that this is only due to adoption. This is only due to technology. You cannot say that. So that is where in propensity score matching is definitely better than your partial budgeting. In fact, if you look at any econometric text, they don't even consider partial budgeting as a method for assessing impact. Yeah. Anyone else would like to come up?
So there is no other question. So Dr. Swastika.
Okay. Hello, Dr. Aditya.
Hi,
How are
sir.
you?
How are you?
Yeah, thank you very much. First of all, I congratulate you for delivering such a wonderful and very informative and a very practical way. You have delivered the lecture. I think our participants might have benefited a lot out of it, and they will take it for their future programs for research and all. On behalf of participants, Dr. Aditya, and as well as from on my personal behalf and as well as on behalf of my institute, we really thank you for delivering lecture, and I hope in future also will be having close collaborations, and our participants also will be having contact you, because many queries they will be having afterwards also, so we may trouble you again, and we'll bring some questions whatever our participants ask to you. I hope you will be happily reply all those things, all queries, and at the end I once again thank you very much for delivering such a wonderful lecture. Thank you.
Thank you so much for.
I think our participants, please clap here. At least he is such a young man, how theoretically and practically he through with the subject. Okay, so thank you very much.
Thank you, sir. Thank you.
Thank you, sir.
Thank you, everyone.
Thank you.
Nice meeting you all. See ya.
Thank you, Doctor.